Hello and welcome back to module number 3. In this module, we are going to talk about two things. One is that we are going to add another variable to our analysis, and in this case it's called Bivariate, and we will learn about techniques and methodology to analyze two variables. And then we are going to talk about R programming. I will give you better structure to what is the R and why is it so powerful when we are doing statistical analysis. But before we move into the content of the class today or module today, you need to be aware that in the module you also have your first quiz. And the first quiz is about descriptive statistics. So the objective of the quiz is not to see if you can answer it correctly or not, is to see where the problems is. As you learn from my vocabulary and how do I express things, I will need to learn from your vocabulary, what you understand from my notes, and how can I improve that. So it's both way that we need to learn how to communicate and better share. And again, to those who has problems, issue with the material, please come see me at my office, or you can Skype with me or email. It doesn't matter to me. Please communicate. Otherwise, we are going to move quite fast as time goes by, and I don't want to leave you behind. So let's start with the module. So far, we talked about descriptive statistics, and when we talked about descriptive statistics, we talked about one variable. We are taking the entire set, we consider it to be one set, but we never talked about, in descriptive statistics, we do not talk about relationship. Example, does blood pressure level predict my life expectancy? Or does the SAT score predict your performance in college? And if you eat a lot of chocolate, are you become smarter or not? Those are type of relationship that we are going to examine in this module. The best way, and again, I am a very visual person, the best way for us to illustrate the idea of the relationship between one variable to another, or two variables, is scatter plot. And let me illustrate the idea. Example, I'm in the age that I usually measure my age and my fat. And so the following data is collected in a study of age and fitness and in humans. And as you can see, the lower number is 23 and the higher number is 61. And so what is the relationship between age and fitness? And so the idea of scatter plot is to show if there is a relationship, positive or negative relationship between age and fat. And we are assuming that as you get older, you become fatter and fatter. I don't want to say anything about that, but this is what we are trained to think. And so this is the idea of measuring, going out of our room, measuring actual people, and to see if this assumption or this idea is actually true. And so by doing that, the scatter plot allowed us to see if in the data that we collected, is it true or not? Another example is advertising and sales. And again, we can see that there is a direct relationship between advertising. The more advertising the company produce or promote, the better sales they will receive out of it. So the scatter plot is great with regard to identify the relationship between two variables. There can be a positive relationship or a negative relationship, but there can be a case there is no relationship at all. So the idea is that we are going to see a straight line that can be upwards or downwards or cover no patterns at all. And by doing it, we can assume or we can associate with how strong is the patterns that we found in the two variables. Is it weak or is it strong? And are there unusual observation? And are there outliers? And this is important. Again, we are trying to see if there is a positive relationship. In this case, is a positive relationship or a negative relationship or no relationship whatsoever. And in this case, there is no relationship. Now we are entering the idea of the analysis of the examination of two variables, and the first idea is the correlation coefficient, and coefficients come in many forms. It helps to determine the relationship among points or value in terms of whether they change together or separately, which is important. And generally, the correlation coefficient of a sample is devoted by the small r, and the correlation coefficient of the population is devoted by p or capital R. In other words, if we will take a sample, the correlation coefficient will help us to determine what is the change in, and those changes happen together or separately. Example, in the cases that we saw with the fat and age, if we will do correlation coefficient with regard to age and fat, is it come as you get older you become fatter, or is it separately? That is something that we like to know, and that's what the idea. So the correlation coefficient is a value range from -1 to 1, and the correlation coefficient -1 indicate strong negative correlation, where the 1 indicates strong positive correlation, and 0 indicates a weak correlation. So how do we provide interpretation to the R? This is the value that we are looking at in order for us to determine what does it entail. So the sign R indicates direction of the linear relationship, and if it's equal or smaller or equal to 0, there is no relationship. As I said, -1 is a stronger relationship, either positive and negative, and all points fall exactly on the straight line. It is when it is equal 1 or -1. So again, this is the indicator. This is our scale in order for us to apply that. So what is the formula for that? Everything as in statistics comes with a formula. How do we compute correlation coefficient? And that's the formula. As you can see, we have x and y, which is the two variables that we want to measure. The n is the total number of variables we have in the set, and this is what we do. Example, years and weight. And as you can see, this is what we apply, this is how we calculate, and we will end up with x multiplied by y, x square, y square, in order for us to apply what it is entail, which will give us in the end that the result is 0.759, and by doing that we will be able to report that there is a strong direct correlation between fat and age. Another example, anxiety and test. And again, anxiety is X and test score is Y. And again, the same idea, the same procedure. And again, we find that the R is equal to minus 0.95, which indicates a strong, indirect, strong correlation. The next example, or the next formula that we will cover in this module, is person sample correlation coefficient. and it measures the strength of any linear relationship between two numerical values. It is based on the idea of best fit through the data points of the two variables. And in this case, we are adding the value of 0 indicates that there is no relationship between the two variables. And the formula, as anything else in this class, we will learn about the formula. What does the formula stands for? And in this case, you can see the equation, the number of pairs of sources, the number of products, the sum of the x scores, the sum of the y scores, and the sum of the square x score, and the sum of the y scores. And by doing that, we are able to do that. In reality, it will look something like that. And this is an example from, again, example of the SAT versus the GPA, and see what it tells us about 10 students. So in this example, I'm using the text from my textbook in page 82. And again, visiting to a special library collection and visited to old archive rooms. And again, the total, the mean, and what does it stand? What does it entail when we apply all the calculation, additional calculation, the x multiplied by y, the x squared, the y square, and what does it entail? And now we're going to apply the person R in this example, and in this case, this is what it will look like, and we will be able to visualize that there is some relationship. It's not strong, it's not straight line, but there is a strong relationship, and it goes up, which means that there is indication that there is effect. In R, if we are going to apply that, again, I'm going to talk about R in the when I finish this subject, but in this case, I want just to highlight how easy it is to do that in R. That's why I'm so in love with R. In this case, we have two containers. The first container is for the value of x. The second container is for the value of y. And so the two values is then being typed into core text x and y, and it will give you a person product movement correlation data, which will give you the value of x and y. It will give you df and p value, and it will give you also when you're going to talk about hypothesis. We are not there yet. We will come to it, but we will talk about that very soon when we are going to talk about the idea of what is the hypothesis, is what does it entail. So next, the Sipperman ranking coefficient, and it is another way for us to measure two variables, and it names after Charles Sederman, and often devoted by the Greek letter of P2 or rho, and it is non-pragmatic measurement of the statistical dependence between two variables. So again, I'm going to start talking about the scale that we are measuring the data, and in this case +1 or -1, and we are going to talk about our rank, which is equal 1 minus. So in this case, the formula is a little bit more scary than what we have learned so far. Yes, it is. But again, we will try to make sense out what does it entail. So when we are talking about ordinal data, it is already in rank. And the interval or the ratio data, we need to convert it into ranking data. Direct example from our textbook, and the library user participate in event that was organized by town council. There were two events. The first was bicycle race, and the second was cooking a dish that was based on the local farmers market. And so the library selected 5 users, often read about the bicycle and the cooking from their collection. So the data also apply what is the difference between them. So we have 5 people with what type of books that they read: cooking books, cycle books, and we have the D1 and a DI and the DI square. And by doing that, we can start applying the Sherman formula. In this case, the D square is equal 4 plus 1 plus 1 plus 1, which will equal 8, is the sum of the square of the difference. The n has to be the sample size. The n square is equal 25 because it's the sample size squared. And so the issue here is that R rank is equal 1. And in this case, we will apply the Sherman in the R. See, almost the same contents as we did before, but in this case, the method is the Sherman. And in this case, R will provide us that the S is equal 8 and the p-value is equal 0.35. If we will learn about p very soon, and we're going to see what does it entail. But right now, I'm just concerned about what is the idea behind it. Why are we so concerned about measuring two variables? In this case, a sample. And it also will give us the idea if we will have hypothesis, if it's true or not. So in summary, what we cover here, and you will have a lot of reading to do in this module, is about analyzing two variables. Often we define them as X and Y for the purpose determining the type of relationship between them. And in this chapter, we review correlation analysis, and in particular Pearson correlation coefficient, and the properties of Pearson R, and the correlation and causality. We will also examine those through R. I will employ R in the following example. So again, this is the example that I can do in R. This is a small container. In this case, it contains only 5 variables, and I'll post it in your assignment or in the module. And as you can see, it will run and it will give me the idea what does it entail. If I want to test the Sherman testing, in this case, this is the code that you will see. I'm doing core test X and Y because the two variables are labeled X and Y, and the method is Sherman, and it will give me the result out of it in order for me to address. Again, this is the result. So I hope that makes sense. I hope that it will give you some background of how to do that. I will give you more links and more information. But now I want to start talking about the R programming structure, and which is important by itself. So R lets you save data by storing it inside the R object. For example, you can save data into the object like A and B, like we did in X and Y. So whatever R encounters as the object, it will replace it with a data saved inside. So in this case, I set object with a value of 1, and I call it A. If I will ask the R, A plus 2, what does it entail? He will tell me that A plus 2, it will equal 2 because the value of 1 the value of A according to R is A as you enter. Good names versus bad names. I prefer that you will not give complicated, do not give dollar signs, do not give square bad or square root or bad names. Try to make it as simple as possible because it is part of the language, the R language. What is a function in this language? So in programming, is a style of programming that emphasizes of the evaluation of the expression rather than the execution of the commands. The idea here is the function is basically the execution of the commands that you are already going to design by yourself. So you will design basically functions that will be executed and be employed by the R environment. Let's see example of a function. R comes with many functions. Example, the mean. When we calculate the mean, it is a function, it calls a function. So basically, when I write the mean and I will say to the R, calculate the mean of 1, 2, and 3, and it will come back to me with an answer, it is a function that already embedded into the R, and we can evaluate that and add more function to it. Here is a list of all the functions in R, and I highly recommend that you will see it just to have better sense why is R so powerful with regard to its functions. The data that you pass into the function is called the function argument. So you basically put in an argument into the R, and by doing that you are able to calculate, do statistical analysis to the function, using the function in order for you to get the result. How do you write your own function? It is example. So you have a set of data collected and you want to add a replacement, a sample replacement. When a sample unit is drawn from infinite population, it returns so that the population that after it's have some characteristics have been recorded before the unit is drawn. So the sample is to be placed with a replacement or without a replacement. So without a replacement, we can say replacement true or false, and by doing that we are writing our own function. I gave you an example here that I want you to go over and see what does it entail with regard to sampling with a replacement and sampling without a replacement. And that's basically a function, and a function that you basically decide based on your data. There is also a function that in R that are first class object, which means that they can treat it like any other R object. Most importantly, object that can pass an argument to other functions. So function be nested so they can be defined function inside another function. So every function in R has basically three parts: a name, a body, and a set of arguments. To make your own function, you need to replicate those parts and store it in the R. So the syntax of the function in R: function has to have a name argument which potentially have a default values. The formal arguments are the arguments inside the function definition, and the formulas function returns a list of all formal arguments if the function, not every function, and this is really important, cause in R makes it a formal argument. So let's take example of normal distribution, and we will learn about that in chapter 7 and 8, and I will give you as a reference in your assignment, the reading assignment. But in this case, the R command to normal distribution is R norm, or if you have probability destiny function, which is the probability of distribution, is D norm, and again different settings and different syntax that attach to those functions. And that's what I want you to understand. If we are going to do calculation or measurements of random normal distribution, it will already, if we will use this command, it will entail the norm, the mean, the standard deviation in order for us to generate that. So example of the code in normal distribution, and I gave you an example here. Again, the length of a book, and this is what it will stand for. And again, another issue that we need to address with the R is the vector. A vector is a sequence of data elements of the same basic type. So the members in a vector are officially called components. They are often used as members in this site or this class or in our environment. So here is a vector containing 3 numerical values. 2, 3, and 5. It is held as a container, and so we can add as a vector if it's true or false, and then this is another value to the set. So the vector of logical values, true, false, true, false, true, false, and again it can be hold a vector that contains the character as a string. So A, B, B, C, C, and in this case will indicate the number of vector is given in the length of the function. So in this case, what is the length of this function in the last command is 5, because we have A, B, C, D, and E. So using the logic vector as an index is also part of what we will learn in this class when we will start doing more advanced statistics. And in this case, we can assign an index to that value in order for us to have based on value smaller or bigger than 0, and by doing that we will have the ability to filter out values out of it. So using the character vector as an index will give us example in first, second, and third, and we'll give them a value. And by doing that, it will already embedded those value and will be able to give us some indication what those values are. We can modify the vectors, we can assign the vectors, or we can even delete the vectors. What is a matrix? A matrix is a two-dimensional data structure in R, which means that a matrix is very similar to a vector, but it can have two-dimensional attributes. Example, sorry, my PowerPoint here just went off scale. I will fix it so you will have that in more context. So in this case, the A is equal to 2, 4, and 3, and 1, 5, and 6, and it is organized in a matrix form. And in this case, in R, we can say matrix, and it will give us the same scale, the number of rows, the number of columns, and by do that, we can organize, sort the data based on it. So this is really important, and I will try to make more sense out of it later on in the semester when we will use it. A list in R. A list is a generic vector containing other objects. For example, the following variable x is a list containing copies of 3 vectors, n, s, and b, and the numeric value of 3. So in this case, we have the n, which is numerical value of 2, 3, and 5. We have the s, which is AA, BB, and so on. But we have also the b, which is true or false. And if we will combine them in together and we will apply as a list, it will list us all those components, all those vectors into a place where we're going to display that in a square bracket, and we'll be able to see what those listed are in order for us to declare them. We can also store a whole number or integer that can be both positive and negative. To declare an integer variable in R, we use the function called sinteger. And so we will be able to identify it as an integer and apply that. in the example, x is equal to as integer minus 3, and when we will ask the R what is the value of 3, it will say minus 2. Note in the line 2, in line 2, where he will pass it and he will display what does it entail, what class it embedded. In the idea of a string is a data type of integer that present in the form of text rather than numbers. So the string in R usually consists of text. So it composed a set of characters that can contain spaces and number. For example, hello. And if we will add some values to it, hello and 3, he will observe it and will be able to display it. Characters or character represent a single element such as letter of the alphabetic or functions or number. In order to convert an object into a character, we need to define it for the R to declare that. So we usually say X or Y or whatever value declare you do, and you will define it as character and will give it a value. So in this case, we gave it a value of 0.14, and the strength of the character is now, when we are using two characters together, example, first name Alon, last name Friedman, so the paste is first name and last name, and he will give me that, Alon Friedman. Another issue is the factor, and the factor is explanatory variable multiplied by the idea of the R. So the R as a factor takes limited number of different values, such as variables, often referred as categorical variables. And we will talk about that also. In the textbook, we define categorical variable which represent type of data that may be divided into groups, such as sex, such as height, such as age. To illustrate the color of the hair, it can be black, white, blonde, or gray. And in this case, A, and we will say what is the value or what is the factors that entails. It can be blonde, black, and white. And if we will say what is the in this value on this container, what is the factor, it will list us all of that, and when we will ask specifically, he will list all those variables. So this is the idea of factor when we are going to deal with categorical variables, and we will see that throughout the semester. So the levels is black, blonde, and gray, and note that our factor provides us levels for black, blonde, gray, and white, a level that is categorical to the data it displays. A logical is also part of our vocabulary in R, and it can be true or false. So in R, we have logical values that make a comparison between the variables, and it provides additional functionality when we are adding or subtracting or doing any other things. Example, x equal 1, y equal 2. And when we would say, is x smaller or bigger than y, he will be able to answer us false or true. Another issue that I did not talk about is the import data into it. I will give you a link to R and how the RStudio recommend you to import data to the R. I use it in the old system, how we used to do that in the R terminal, when you have to name the idea. But in today's R, it's quite simple. You will say, okay, I want files, I want to import a data set, and in this case, I will select the data from my database, and I will say desktop. I will go to my long set of data, which I don't find right now. Documents, maybe I have it here. So in this case, I have R. I have data set, and he will say me confirm, he will upload it, and he will upload the data. If you are using Excel or Excel data, he will be able to do that quite easily. And again, I give you how to do that and how to import example data from the web. And again, this is quite easy, and I hope you will be able to follow up on that and be able to import. I know I cover a lot. I cover about two variables. I talked about what is it entail and what is it provides us, and when we analyze two variables. I also talked about the R. I talked about what is the basic idea of the R when we are talking about functions, and I want you to have a list, at least review all the functions that are already embedded in R. It will make you a better programmer, so this is really important. So those are the things that I want you to see. I want you to make space or make notes about all the arguments that the function has. What is an argument? What is a function argument? How to write a functions? What is a sample and what is a replacement without a replacement? What is a syntax of a function? And what is normal distribution, not normal distribution? What is the code for that? So, and what is a vector? And so I cover quite a lot. I hope it makes sense. I hope it will open up your eyes to the R and why is the R so important in that environment. You will have, as I said, you will have a quiz, a small quiz about descriptive statistics, and your assignment will entail, again, analyze two variables to find what is it entail, and also to have scatter plot and post it on your blog and give some discussion about that, just to give more essence what we are doing in class. That's all. I hope you will have a nice week, and I will see you next time. Again, if you have any question, please do not hesitate to email or come talk to me. Until next time, have fun.